one thing I didn't do, I forgot to do, I've got to do it now. Whoops. Okay. I didn't end my last class. I mean, I ended the recording, but I didn't come off of that. Okay. It's not here either. We're in 4.2. This what I did. Okay. All right. Yep, that's where we are. So let's go from current slide. And we're recording, so let's start from there. But before we begin there, let me make a few announcements. I wanted to get this while it was on Screencast-O-Matic, and will be uploaded. Finally, over the weekend, I can't remember when over the weekend I got this one done, but I did get the syllabus updated, and I got it on Blackboard. And just to remind you where things are on Blackboard, when you go to the home page for this course in Blackboard, there's a whole series of blue tabs over here in the, it's basically the whole left column here. You scroll down and it continues, and then you get to some other stuff there. Everything you need is on that first scroll. You don't have to page down any. Something like the second or third tab on the instructor side, I assume it's similar to the student side. I don't get to see your side, so I don't know for sure. Those blue tabs, it says something about syllabus and something or another. If you click on that, you'll see the syllabus. It's out there. Okay. Then you, the very next tab on the instructor side, it says instructor information and more, something like that. So on that, I put my locator card. It shows when I'm on campus, when I'm off campus, when I'm in class, when I'm out of class, when I'm at lunch, which campus I'm on, all that kind of stuff. On one page has just where I am. It's the same thing I have posted on the office door. Okay? And this is Josh? Huh? It is, okay. All right. Okay. And I was talking about all the things are out there on Blackboard now. And on the Blackboard homepage, one of the first few tabs in the left-hand column, a whole bunch of tabs go forever, it seems like. Like the second, third one, it says something about syllabus. That's where the syllabus is. And then the very next one on the instructor side anyway says instructor information. So that's where I put my locator card. So all that's there. Then you go on down near the bottom of that first page. You'll see something that says class handouts and more. Okay? And on that one, if you click on that, you'll see the research paper instructions. That'll be the top thing. And then every PowerPoint that we could possibly use in these three chapters, 4, 5, and 6, I put them all out there. We may not get to all of them, but I put them all out there. They should be there now.
Under class handouts?
Class handouts and more. You got it? Okay. And then after all the PowerPoints, there's a whole bunch of those. After that, you'll see something like 4 or 5 websites, okay? And those are things that either I found or students have found, said they found helpful for the course, so I put them out. Now, a couple of those I noted, they have the old edition of the book, not the new. And if you can navigate through that, try. If you can't, I'll try. The last time I tried, they didn't even have available the new edition, so I didn't try this time to see. But there's very little change between the editions. Okay, and then after that, finally, is that last, it's a web link also, but it says Math 113 YouTube videos. Okay, and if you click on that, here's what you find. You find a huge playlist, I don't remember how many
20, 30, something like that, of things. Now, the ones at the top will be 4.1, 4.2. Those are the last time I taught the course, which is probably last spring or fall. You have to go to the bottom of that, and you'll see the last four are the ones we've done so far. After today, it'll be 5. The syllabus, that's where it begins, and then research paper, or whatever, and then goes on 4.1 and beginning of 4.2. Those are this terms. There is a reason I don't take off the others, because every now and then something will screw up. Screencast-O-Matic doesn't work. The server doesn't work. The supercomputer doesn't. Something will be screwed up, and I can't do the new one, so you'll have at least the last time I taught the course, you'll have that to go by. All right. Any questions? Okay. Now, here's where we left off last time. So I just wanted to point this out to you too. The PowerPoints are out there in static form under the top part of class content, or class handouts and more, but then they're also in the YouTube videos, because that's what I teach from. So you'll either have it static up here or dynamic down in the YouTube videos. So, this figure right here, 417, the unit circle is divided into 8 equal arcs, and we were talking about this last time. Now, I think we got started on this. Each one of these is, okay, the entire unit circle would be a radius, because it's a radius of what unit circle? 1. Then the circumference is just going to be 2 pi. That's going to be the arc around that. And halfway around would be pi. A quarter way around would be pi halves. And an eighth of the way around would be pi fourths. So this is pi fourths. So here's 0, pi fourths, pi halves, 3/4 pi, pi, 5/4 pi, 3 halves pi, 7/4 pi, and 2 pi. All the way around. And we already know what the values are on the unit circle, because we did these earlier. This is the line where y is equal to x. So therefore, that's going to be root 2 over 2, root 2 over 2. You can check that out by doing the square root of this. The square root of this squared plus that squared. This squared would be 2 over 4, 1/2, plus 1/2 is 1. Square root of 1 is 1. That is the unit circle. Everything's correct there. And then the only difference here, this is minus x, the same y. This is minus x and minus y. And that's positive x, negative y. All right, here's Jake. Oh. Okay. So we're only missing Gavin. He may be in later. And then, of course, Jake Williams, whom we haven't seen from the beginning. All right. Any questions on this? I think we went over it last time, just as a quick review. Okay? We did go over it. I thought we did. Okay. So, if we split that unit circle into 12 equal arcs, okay, now this time we're going to do one way all the way around is 2 pi, pi, pi halves, okay? Now that pi halves will split into 3 equal parts. This is divided into 4 equal parts, okay? And then divide that into 3, that gives you your 12 equal parts. So this will be pi halves divided by 3 would be pi 6, pi thirds, pi halves. Okay, let's start it over. 0, pi 6, pi thirds, pi halves, 2/3 pi, 5/6 pi, pi, 7/6 pi, 4/3 pi, 3 halves pi, 5/3 pi, 11/6 pi, and 2 pi. So you're all the way around that. Now this one, remember from before, from your equilateral triangle, you know that this, the y value here is exactly half your unit circle, right? Because since this is an equilateral triangle, the y value is exactly 1/2. Because each one of these is 1, that would be a 1, so it's that pi sector, that would be 1/2. And to be on the unit circle, that would make this have to be the square root of 3 over 2. Then this one reverses those. Your 1/2 this way, and square root of 3 over 2 on the y-axis. and then 0, 1, and then from then on, you just negate the x, keep the y the same, negate the x, keep the y the same, negate x and y, negate x and y. This is just 0 minus 1. You know that one from before. Here you keep the x positive, the y negative, x positive, y negative, and you're back where you started. Okay, so you know all those values. You know, and if you know the ordered pairs, what else do you know? All 6 trigonometric functions. Because what's the sign of, pick one of those. Pick any one of those. Anybody, pick one. Say again? Pi 6, this one right here. Okay, what's the sign of pi 6? The sign is y. Y value, 1/2. The cosine is root 3 over 2. The tangent is this one over that one. The cotangent is that one over that one. And the secant is 1 over this one, and the cosecant is 1 over that one. So you just flip those. So you know every one of the trig functions for every one of these angles. Just like you know them for every one of these. Because pick one of those. Any one. 3/4 pi. Okay? And find 3/4 pi. There's 1/4 pi, 2/4 pi, 3/4 pi right there. Okay? What's the sign of 3/4 pi? Root 2 over 2. What's the cosine? Negative root 2 over 2. What's the tangent? -1. The cotangent? -1. The secant? Okay. Yeah, -1 over, right. It's negative root 2. We flip those and re-rationalize the denominator. You wind up with negative root 2, and the cosecant would be root 2. All right. So you know every trig, all 6 trig functions for every one of these angles are values, and every trig function for every one of those, because you know the ordered pair. So look how much information you have just from this. These are the t values. Later we'll call them angles, but they're now calling them t values. Okay? And you know the trig values for all 6 trig functions for every one of those trig values. Okay. So, to verify the points on the unit circle, note that root 2 over 2 also lies on the line y is equal to x. We already did that, right? That's how I showed you why that was root 2 over 2. Substituting y for x, you did this. We did all those things. We got plus or minus root 2 over 2. The plus is up here, the minus is down here. The plus is here, the minus is up here. So, okay. Because the point in the first quadrant, y is equal to x, root 2 over 2, y is root 2 over 2. We went through that exercise before. Any questions about it? You see why that's true. So that's for your quarter pies, okay? Everything you need to know about your quarter pie right there. And your 12ths of pies, when you divide the unit circle into 12 pieces, but that would give you your 6ths of pies and 1/3 of pies, okay? It says you can use similar reasoning here, but they don't tell you what the reasoning is. I showed you already. It's the equilateral triangle that's formed from any one of these things. Like just draw the line straight from there to there, okay? That forms equilateral triangle. How you know that is if this is pi 6, that's pi 6. Add those together, you get pi 1/3. And these two angles have to be the same, because everything's similar to it. And twice this angle plus that angle, which is pi 1/3, has to be pi, 180 degrees pi. And you see it has to be an equilateral triangle. Those two have to be the same. And as soon as you know that, then you know this is 1/2 here and 1/2 here. Negative 1/2 here. So you know those 2 points. Once you know those, you can do from being on the unit circle, x squared plus y squared is equal to 1. That has to be 3 from there on, everything else follows. Everything else follows. So those are your t-values for dividing it into 12 equal pieces. And once you know the t-values and the ordered pairs, you can find the trig functions, all 6 trig functions of every t-value of those 12. Okay. Any questions? Okay. So let's do it. We said we could. Evaluate the 6 trigonometric functions at each real number. T equal pi 6. Let me get my pen activated here. Okay. So what's the sign of pi 6? Okay. Now you have to think back. What's your, basically to begin with, what's the ordered pair that corresponds to pi 6?
1/2.
Okay, the sign is 1/2. The ordered pair is root 3 over 2 1/2. So therefore the sign is 1/2. What's the cosine of pi 6? Root 3 over 2. Perfect. And what's the tangent of pi over 6? Now here's the easy way to do it in my mind. This is why I write them this way. Tangent is sine over cosine, so just put a division line there. The 2's you can divide out, and that would be 1 over root 3. Right? But if you don't like having a radical in the denominator, what would that become? I'll actually do the math for you this time. If you don't like having a radical in the denominator, rationalize the denominator. Multiply by itself. Then you have to multiply the numerator by the same value, and that would be 1 times root 3 is root 3. And what's root 3 times root 3? 3. Root 3 squared, which is square undoes the square root, and you get root 3 over 3. Does that make sense? Now, right now, they want you to write it this way. A little bit later, they'll write it as 1 over root 3. They're the same answers, okay? They are the same, okay? Now, what is the cotangent? This is how I like to write it. Cotangent of pi 6. Now you call on that reciprocal relationship. Cotangent is 1 over tangent. 1 over tangent. So that would just be root 3. There you go back to this form that we wrote down to begin with, and just flip that over and that's root 3. Does that make sense? Okay? And then secant of pi 6. What's that? Yak. It's what? Okay. My hearing's really bad. I couldn't make out what, I could hear you saying something, but I couldn't make it out.
Would it be 1 over root 5?
Okay. What you do is flip this one. It's 1 over cosine, so that'd be 2 over root 3. Now, a lot of people don't like having radicals in the denominator, so what could you do? Yeah, multiply it by itself in the denominator, but then you multiply the numerator by the same thing. And why can you do that? What is root 3 over root 3? 1. And when can you multiply by 1? Anytime you want to. It doesn't change the value at all. So what does that give you? 2 root 3 over 3. Because root 3 times root 3 is just 3. Okay? And how about sine of pi 6? I mean cosecant of pi 6. What would that be? 2. You just flip. It's 1 over sine, so just do the reciprocal of sine, 2. Now, here's a little hint. We haven't really gotten to this yet, but let me tell you because it's true. Okay? And we have gotten to the first part. Sine and cosine are always in between -1 and +1. Always. If you ever get a sine or a cosine that's 2.7, wrong. It can't be there. Or -1.3. Wrong. It can't be there. It has to be between -1 and 1. Always. Tangents and cotangents can be anywhere. Positive, negative, from positive infinity to minus infinity. They can be anywhere. So there's not much you can tell on those, except if one's greater than 1, the other's less than 1. Okay, because they're reciprocals of each other. Then, the secant and cosecant, because they're reciprocals of things that are between -1 and 1, they are going to be outside -1 and 1. Sine and cosine have to be in between -1 and 1. Secant and cosecant have to be outside. So therefore, this has to be something greater than 1, greater than 1. Both of them. Ever have a secant or a cosecant that's 0.7? Wrong answer. It can't be there. Okay? It's got to be greater than +1 or equal to +1 or less than or equal to -1. That's just a little thing to look at and make sure. So punch them in on your calculator, make sure these two are greater than, the absolute value is greater than 1, the absolute value here has to be less than that. Or equal. Both of them can be equal. Okay. So, let's, because this one is the very first one they're going to do, let's do it while we're still thinking of it, and let's see what answers they get. For each t value, begin by finding the corresponding point xy on the unit circle. That's exactly what we did. Identify that point, and that was √3/2, 1/2. As soon as you have that point identified, you have all 6 trig functions. Okay? Sine of pi6 is your y value, which was 1/2. The cosine was the x value, which was √3/2. The tangent is the y/x, which is just sine divided by cosine. Just do a division line there, divide out the 2's, and you have 1/√3. They put 1/2 over √3/2. And then what you can do is just cancel out the 2's, divide out the 2's, multiply out the 2's, however you want to say that. You get 1/√3. And just because sometimes they don't like writing radicals in the denominator, you can write that as √3/3. Okay? Just like what we did. Now, they're going to start over, I think, at cosecant, which is fine. Yeah, and it's just 1/y, which is a reciprocal of sine, 2. 1/1/2, which is 2. And then the cosine is secant is 1/cosine, which is 1/x. And that's going to be 2/√3. And then to rationalize that, you get 2√3/3. And then the cotangent, which I usually do before this, is x/y. That would be √3/2 over 1/2. Multiply out the 2's, and you get √3. Done. Make sense? All right. So let's go back. That's one reason I didn't want to do it this way. Go back here and do the B part. Now, what's the first thing we do? Yeah, where are you all day? So what is your ordered pair that corresponds to 5/4 pi?
Negative radical 2 and negative radical 2.
Okay, negative √2/2 and √2/2. Okay, perfect. Okay, how do you know that? Because wait. Negative. Okay. You said it and I didn't write it. Okay. 5/4 pi. Okay. Here you are. 1/4 pi, 2/4 pi, 3/4 pi, 4/4 pi, 5/4 pi. You're down here in the third quadrant. Everything's negative there. And everything's, for the quarter pies, everything's √2/2. Just adjust your plus and minus signs. And these are minus. So you got it. So now we can write down
everything we need to know. What is sine of 5 pi over 4? Anybody? Negative root 2 over 2. Perfect. It's the y value. And cosine of 5/4 pi is, second, same thing. Negative root 2 over 2 is the x value. Okay? And it's on the line y is equal to x, so it's got to be the same. What's the tangent? Yes, of 5/4 pi is 1, because it's the ratio of those. What's the cotangent of 5/4 pi? It's 1 too, because it's a reciprocal of that. Okay? Those were easy. Now, how about this one? The secant of 5 pi over 4. Negative radical 2. And the cosecant? Same deal. Okay? Because they're reciprocals of the same two numbers, so they got to be the same numbers. And guess what? These are, the absolute value of these are less than 1, 0.707, something like that. And the absolute values of those are 1.414. So yes, these are less than 1, those are greater than 1. Always have to be. Tangent and cotangent could be anywhere. They both happen to be 1 at this point. All right. We'll come back and look at those. It takes too many flicks to get over there. Let's go on and do the C, which is yes in Spanish. Okay. All right. What's the first thing we identify? What's your ordered pair, and what is that for t equal pi? Negative 1, 0. Okay. So what's the sine of pi? 0, the y value. What's the cosine of pi? Negative 1. Okay. What's the tangent of pi? Ah. No, it's y over x. Y over x. Cotangent is the one. So what's, yeah, that one's 0. And just do this. Just do it. If you line them up this way, it's just 0 over negative 1, which is 0. Okay? And then what is cotangent of pi? That's your Q. Which is? Undefined. Got it. Okay. And what is the secant of pi? It's a negative 1 too, because it's 1 over the cosine. Okay. 1 over x. Okay. And what is the cosecant of pi? Undefined. Perfect, because it's reciprocal of sine, but if sine's 0, it's undefined. You cannot divide by 0. Perfect. See how that goes? All right. Everybody got it? You need it a little longer? Okay. Now let's do the D one. First thing we do, identified the ordered pair. And where are you, Waldo? T equal negative pi thirds. Which quadrant? Fourth quadrant, exactly. And so there your one coordinate is positive, one's negative. No, that's the third quadrant. It's the what? Yeah, so okay, so it's going to be a plus, comma, minus. We just got to fill in the blank now. Okay, what are the values then? Pi thirds. The x's. Okay, the x is positive. What value? Okay, is that the order? Ah, yes, let's try it that way. All right, the x value is the 1/2, and the y value is root 3 over 2. I was going to go elsewhere, but yeah, we'll leave it like that. Okay? So what's the sign of negative pi thirds? Negative root 3 over 2. The cosine of negative pi thirds. One half, perfect. The tangent of negative pi thirds. Okay, say that again. Negative radical 3 over 2. It's just a ratio of those. The 2's go out. Yep, root 3 over 2. Negative root 3. Negative root 3, sorry. Okay, and then the cotangent of negative pi thirds. Negative 1 over root 3 is one way to write it. What's another way? Negative root 3 over 3. Perfect. Okay, in both counts. What's the secant of negative pi thirds? 2. And the cosecant of negative pi thirds? Don't pay any attention to my negative 2 root 3 over 3. Perfect. Way to go. Make sense? Once you have that ordered pair, you got all the trig functions knocked. Just get the ordered pair right. Okay. So we already did the A one. So we'll just scroll through that. All right, now let's do the B one. B was T is equal to 5/4 pi. We determined we're over in the third quadrant, so both are negative. And the XY point, because that's a quarter pi, is root 2 over 2, root 2 over 2, both negative. So your sign is your Y value, which is negative root 2 over 2. The cosine is the X value, that's negative root 2 over 2. Your tangent is the ratio of y to x, which is negative over negative is positive, and the same number over same number is 1. So it's negative root 2 over 2 over negative root 2 over 2, which is 1. And the cotangent is the they go jump to cosecant. So go back up to sine and do the reciprocal of sine, which would be 1 over y. And if you think about it, that y was originally 1 over root 2, negative 1 over root 2. So when you take that value of y and do the reciprocal of it, you just get, they do it, negative 2 over root 2, which is negative root 2. And then when you do the same with the secant, it'll give you exactly the same thing, negative root 2. And then do the x over y for the cotangent, and that winds up being positive 1 again, which is reciprocal of tangent. That's why I like to do the cotangent right after I do the tangent. It's just reciprocal of it. So I don't like the way the order they do it. Perfectly fine. It just doesn't fit my pattern. Okay. So let's do the third one. When t is equal to pi, you're over here at the point negative 1, 0. We're familiar with that, and we've been there before. The sine of that would then be just the y value 0. The cosine would be the x value negative 1. The tangent would be the ratio of those, which would be 0 over negative 1, which is 0. And I like to go to cotangent. They go up to do their cosecant, which is 1 over y, which of course is 1 over 0, undefined. The secant is 1 over x, which was negative 1 over negative 1, which is negative 1. And then the cotangent is x over y, which is
-1 over 0, undefined. So, and here's Gavin. Gives us perfect attendance again today. Way to go, team. We haven't seen J.D. Williams, but I'm guessing she's not showing up. Okay? Way to go. We're in section 4.2 of chapter 4, section 4.2, and we're doing example 1, and we just finished 1D at the bottom of page 272. No, I'm sorry, 1C, which is the lower half of page 272. Getting ready to do 1D. Here's D. Moving clockwise around the unit circle, it follows that t is equal to minus pi thirds, corresponds to the point xy point of x equal 1/2, y is equal to -√3 over 2, which is what we said, right? Yes. Okay? And once we know that, we can write down our 6 trig functions. Sine of negative pi thirds is the y value, which is -√3 over 2. Cosine of the negative pi thirds is the x value, which is 1/2. The tangent of negative pi thirds is simply the ratio of those two, which is going to be -√3. Well, -√3 over 2 over 1/2, which is -√3. Now we're going to jump up and do the secant next, which is the 1 over, no, they do cosecant next, 1 over y, which is -2 over √3, which if we do want to rationalize the denominator, is -2√3 over 3. Okay. Oh, I pulled a muscle over the weekend, so I'm in pain. Okay. Secant of negative pi thirds is 1 over x, and if you remember, the x was just 1/2, so that would be 1 over 1/2, and that would be 2. And the cotangent, that would be x over y, and there we have the x, there we have the y, so it's 1/2 over -√3 over 2, which would be -1 over √3, which would be -√3 over 3. Good deal. Just like we got, right? Good deal. Any questions? All right, that was the end. That was example 1, those 6. And I wanted to point out to you again, I've done it before, but just to remind you, after every example in the book, there's a checkpoint. And the checkpoint, very similar to the example you just did, different numbers, but very similar. And if you want to really master this stuff, as soon as you can after class, if you don't have another class, go back and do your checkpoints. Even, I'd say, before you did your homework exercises. Do them as soon as you can, reinforce what we just did. If you have trouble getting it or want to know what the answer is, I think the answers are in the back of the book somewhere. Maybe even at the end of the chapter, but I believe they're at the back of the book. Actually, yeah. Let's see if they're at the end of the chapter. Different books go in different places. I think they're all in the back of the book. There at the back of the book. But you can go to this larsonprecalculus.com, and they work out those checkpoints for you. So if you can't remember how we did them in class, go to larsonprecalculus.com, and they will have them there. No code required, nothing. You just go there and use the website. All right, any questions on example 1? All right, now we've already been, I've been asking questions about it, and we've basically talked about it. Now we're going to do it formally. What are the domain and the period? And we're just going to start with the sine and the cosine functions. Okay? So, now, here's the thing you have to remember. Up until now, I bet you, most of you, when you say the domain, you say all of the allowable x values. And when you say range, you say all of the allowable y values. Don't do that anymore. The independent variable here for your trig functions is the thing that follows the sine and the cosine. That's the t values. The t values, those are your independent, that's your domain. And then the range for sine is going to be the x's, and the range for, the y's, and the range for your cosine is going to be the x's, because cosine of t is equal to x, and sine of t is equal to y. So, don't be stuck on x, y as your domain and range. Think what's your independent variable. That's the t in both of these cases. The range is your what the function is, the trig function is, the x and the y. Okay? So, from this, the domain of the sine function, the t value can be anywhere from 0 to 2 pi, 4 pi, 6 pi, 8 pi, or negative 2 pi. Domain is all real numbers. For sine and cosine, you can go around and around and around and around. Either direction as many times as you want. Your domain is all real numbers. The range, however, for the sine is between, because sine is the y value, between -1 and 1, and the domain and the range for the cosine is between -1 and 1. And they always stay in there. We already talked about that. So sine starts at 0, goes up and down. Its range is -1 and 1. Domain, all real numbers. Cosine starts at 1, goes down and up and down and up, back and forth either way. Minus infinity to plus infinity is the domain. The range is always between -1 and 1. Always. Never gets outside of that. Okay. Now, functions that repeat themselves periodically are called periodic functions in both sine and cosine. In fact, all your trig functions are periodic functions. Okay? By definition, sine of t is equal to y, cosine of t is equal to x. The independent variable domain is the t's in both cases, and the x's and y's are your dependent variables, which represent the ranges. Because x, y is on the unit circle, you know that the x's stay between plus or minus 1, and the y stays between plus or minus 1. The previous picture showed that. So, the y is sine t, the x is cosine t. So this defines the range, okay? And the t is going to define the domain. But we haven't talked about, we've talked about it. But now, adding 2 pi to each value of t, you just start over again and start repeating the same pattern. That's what makes it periodic. Okay? So add 2 pi to it, and you're back where you started with. 0, 0. When t is equal to 0, your point here is 1, 0. When t is equal to 2 pi, you're back at 1, 0, 4 pi, 6 pi, 8 pi. Minus 2 pi, minus 4 pi, minus 6 pi, minus 8 pi. Every 2 pi, you get the same result. Exactly the same result. So any of the values you know, like t is equal to pi fourths, then do pi fourths plus another 2 pi, and that gives you 9/4 pi, and add another 2 pi to it, which is another 17/4 pi. Just keep adding 2, you're right back there, and your point is still the same, root 2 over 2 minus root 2 over 2. Okay. So you can do that from any one of these points, add 2 pi to it, and you're back there. Pi halves plus 2 pi would be 5 halves pi, and another 2 pi would be 9 halves pi, and another 2 pi would be, just keep adding 4 halves pi to it, and you get the same thing here. Every one of those. Add 2 pi to it. So the shorthand way of expressing that is the values of sine of t plus 2 pi, okay, and cosine of t plus 2 pi correspond the same as sine t and cosine t. Because you're back at the same point. Similar results can be obtained for repeating revolutions, positive or negative, on the unit circle, and that leads to this. The sine of t plus 2n pi. They say 2 pi n, which is fine. To me, it makes more sense 2n pi because n is any integer. When n is 0, that would just be t. That certainly is right. When n is 1, that would be that, and we can solve that as sine t. But then 4 pi, 6 pi, 8 pi, 10 pi, whatever, or negative 2 pi, negative 4 pi. All those are the same as sine t, as are they with cosine t. Add 2 pi to it, you're back at the same value. For any integer n, remember integers are positive and negative, any real number t. The functions that behave in such a repetitive or cyclic or periodic manner are called periodic functions. Okay? That's what we're dealing with. Really all the trig functions, but especially sines and cosines. Okay. So here's the definition of a periodic function. Function f is periodic when there exists some positive real number c such that f of t plus c is always, always, always the same as f of t. Okay? For every value t you put in there. Okay? Every value t. The smallest number c for which is periodic, that's called the period of c. So what's the period for sine and cosine? Two pi's. That's a pi. Okay. 2 pi. That's the period. The smallest number c. Sure, for some, t plus pi is going to be the same, but it's not for every value t. T plus 2 pi, always the same. Now, just another little blurb here. Back in pre-calculus algebra, whenever you may have taken that, you know that a function is even when f of minus t is the same as f of t. Odd when f of minus t is minus f of t. Okay? What that means is, if you go over a certain t value here, and you have a f up here, say, if that's an even function, you go minus t, you're going to be in the same place. Those are the same. But if it's an odd function, you go over t and you're up here, you go to minus t, you've got to be down here. That means they're the opposite of each other. Okay? Now, in regular polynomials and any other algebraic functions, most of the time your functions are going to be neither even nor odd. Occasionally you have an even function, occasionally you have an odd function. Most of them are going to be neither. But in your trig functions, as long as you don't have phase shifts and things like this, every trig function is either even or odd. And we'll see which ones are which. Think about it now. Sine starts here and goes up or goes down here. Guess what kind of function that is? There's your origin. It goes up here, down here. About the same amount. Odd. Cosine, on the other hand, starts at 1, goes down like this, or down like this. What's that? Even. Okay. So your sine is odd, cosine even. Now, tangent is sine over cosine. And if you do odd divided by even in numbers, it's going to stay odd. Okay? And cotangent is 1 over that, so that's got to be odd. Cosecant is 1 over sine, so that's got to be odd. The only one that has another even counterpart is cosine, and 1 over cosine is secant, so those two are even. So that's what this is telling us here. The cosine and cosecant functions are your only two even functions. Cosine of minus t is the same as cosine of t, because they do the same thing on both sides of the origin. And therefore, secant of minus t is the same as secant t. We haven't gotten a good visual image of what those look like yet, but we'll get one a little bit later. Sine, cosecant, tangent, cotangent are all odd functions. Sine, whatever it's doing this way, does the opposite that way. Cosecant is going to be the same because it's reciprocal of that. Tangent is going to go like this, cotangent. So it's doing one thing on one side, the opposite on the other. And cosecant is, cotangent is going to be a sort of weird thing, but it's going to be odd as well because it's 1 over tangent. Okay.
That was sort of thrown in. The periodic stuff is the stuff we're dealing with now.
So let's.
Oh, man. I really don't like the way they do this.
But not much help for it. Okay. If you're trying to determine, say, the sine of a function like that, okay? First thing I would do, I'd divide 6 into 13. What do you get? 2 and 1/6. So that'd be 2 pi plus another 1/6 pi. Okay? Which is exactly what they do here. Divide that, you get 2 pi plus the remainder of 1/6, which is 1/6 pi. Well, now you know this is one period of sine. So this is going to be exactly the same as sine of pi 6. Now, what is the sine of pi 6? Where are you? Huh? Okay. You're giving me the coordinates, which is the
First thing to do when you have pi 6, that represents, and what do you say those coordinates were again? Radical 3 over 2, 1/2. Okay? And the sine of that is 1/2. Okay. So this would be 1/2. Now they're going to take a few more steps to get there, but you know the answer already because sine is periodic with 2 pi. Okay? So that's the same as sine of pi 6, and sine of pi 6 is 1/2. Perfect. Okay? Now, all right. I'm going to do the B one here without showing the answer. They show the answer and then do it. How about negative 7 pi over 2? What would be a good first place to start there? Second?
Times 2 go into 7.
Okay, I would start there, and what would that give you?
The 3 something.
Yeah, it'd be 3 pi, negative 3 pi minus another pi halves. But 3 pi isn't a multiple. So actually on this one, when I don't see a multiple, what I'm going to do is subtract 2 pi from it. But 2 pi is how many half pi's? 2 pi is what? How many half pi's? 4. That would be 4 half pi's, right? Just multiply numerator and now do that subtraction and what do you get? Oh, I'm sorry, add, because that started off negative. Add 2 pi to it. What does that give you?
Negative 3 halves pi. I can deal with that. Where is negative 3 halves pi? So you got to go clockwise, right? 1 half pi, 2 halves pi, 3 halves pi, right? That's the same as what? Pi halves. Now that's how I would approach the problem, okay? I first would do what you did and saw that I don't get a 2 pi out of that. So then I'd say, well, let's subtract 2, or in this case, add 2 pi because it was already negative. Add 2 pi to it. Go one thing around from it and see where we are. Negative 3 halves pi. Negative 3 halves pi is the same as positive. And in fact, the other way you do it is add another 2 pi to it and you're going to wind up with pi halves. So once you're there, you know what your ordered pair is. And this is equivalent to pi halves. And what's your ordered pair there? 0, 1. Is that what you said? I thought it was. Okay. Yeah, okay. 0, 1, right? Now we can do, and what are we looking for on that one? Cosine. We're looking for cosine. What's the cosine of pi halves? 0, the x value. Perfect. Okay, we'll go back and see how they did it. Let's do then the third one here, and that's a completely different kind of problem. Okay, and the third one, the C one, says for, I'm going to erase this so I'll have more room to write. Okay, okay. It says for sine of t equal to 4/5, right? What is sine of minus t? Any guess? Sine is what kind of function? Odd. So what would that be? It would be the opposite of this one. That's what odds mean. The sine of t is 4/5. Sine of minus t must be minus 4/5. The opposite value. So minus 4/5. That's all they're asking for. They're not asking for what t is. They're asking just what sine of minus t is.
So this elsewhere, that's 2 top.
What's that again?
This elsewhere on top.
What about on top?
Oh, that's the elsewhere.
The answer right here? Yeah, that's the answer. Yeah. And actually what the problem was, and this just sort of drives me nuts, for this, that, because that is odd. They give you the answer and say because it's odd, they don't even ask you to find the answer. So I get a little perturbed at that kind of a question. Now I'll go back and show you what the questions are. Okay, we've already done the A part. Okay, and we saw what that was, 1/2. Okay, let's move to the B part. And here's what they say. Because minus 7 halves pi is minus 4 pi, and that's why I say minus 7 halves pi, you're going around and around. So just, that's minus 4 pi. They're doing it slightly different. I would have added 4 pi to that and done it, but they say that's the same as minus 4 pi plus pi halves, which is true too. This is minus 8 pi halves, and that's minus 7 pi halves plus pi half, okay? That's true. And because this is an even in pi, 2n pi, then you just have the cosine of this would be the cosine of that, which is just the cosine of pi halves. To me, a sort of bizarre way to do it, but it's certainly true. It's certainly true.
Okay, and that's the same as cosine of pi has. And what is cosine of pi has? 0. Were you going to say something? Oh, it looked like you said something. Is 0. All right, and then this one. For sine of t equal 4/5 pi, sine of minus t is equal to minus 4/5 pi because sine function is odd. That was the problem. How do you give an answer to that? They've given you everything you need. I mean, they gave you the problem and the answer and told you why it was true, and I don't know what you were supposed to do with that. So that's why I said, let's do it separately. That's why I wrote them down separately. Okay. Now, that was example 2, and just like in every example, immediately after the example is a checkpoint, and it has 3 similar type questions to it. And if you can't get those questions, then somewhere in the back, let me just see, I think it's chapter 4, it's a long chapter. No, I really don't see the checkpoints back here. I thought they were. So you can just go to the website, larsonprecalculus.com, and check and see if you get it right. But most of the time you're going to know you got the right answer anyway. You don't have to fiddle with it. Okay. So, but there's a checkpoint every one, and try to do those as soon as you can after class. All right. When evaluating a trigonometric function with a calculator, the number one thing you have to always keep in mind, you have 2 sets of things you can do a sine function with. You can do it with angles in degrees or angles in radians. Okay? Be sure you're in the right mode. Now, it depends on the type of calculator you have, how you get to the right mode. If you have a simple little scientific calculator, usually they print the mode on there, and it'll start off the default is degree. If you want to change modes, there is a key that says either D point to R or R point to D or something like that. If you have a graphing calculator, there's usually a mode key on it. And when you press the mode key, then it gives you a bunch of modes. Find the ones that deal with radians and degrees. Make sure you're in the right one. A lot of times there will be a third option called the grad, and we aren't dealing with grads yet. You'll get into that in calculus. So you're stick with radian or degree. So make sure you're in the right mode first. How do you know what mode to be in? Yeah, how can you tell that?
Radians will have well, if it's a degree, it'll have a degree sign.
Yes, that's the key. If you have in degree mode, you've got to have that degree sign. If you don't have the degree sign, you're in radian mode. A lot of time you look for the pi's in those. That's not always sufficient. Just as long as there's no degree, you're in radian mode. If there is a degree, you're in degree mode. So most calculators do not have keys for cosecant, secant, and cotangent, so you can't do them, can you? Sure you can. What is a secant? 1 over cosine. You have a cosine key, so do your cosine. Then do, if you have a x to the minus 1 key, that's your reciprocal key. Other calculators may have 1 over x as your reciprocal key. Use that, or just divide by it. Sometimes the reciprocal key is harder to do than the other. So do your reciprocal of that. So that's how you use your calculators. Here's an example. If you were trying to evaluate the cosine of pi eighths, okay, there is no cosine or cosecant key on your calculator, so find the sine key. And you can do it either this way. If you do it this way, brute force. 1 over sine of pi eighths. And you can
put your pi 8s in there. Once you do the sign key, usually you have an open parentheses there. Then you do your pi key. Most calculators that do sines and cosines will have a pi key. Divide it by 8, close that parentheses, then press equal. Or, a little bit easier, is just as soon as you see this, do sign key, sine of pi 8s, and then hit the reciprocal key. That's what they're showing down here. Now, the disadvantage of doing it this way is you've got to remember to open up with a parenthesis to begin with. If you just do sine of pi divided by 8, close parentheses, and then do your reciprocal key, what are you going to get? It's going to reciprocate the 8, not the pi 8s or not the sine. That's why you have to open with a parentheses here and close with a parentheses there, and then do your reciprocal key. So basically what I do is if I'm doing it this way, I actually do this because to me that's just easier. Just brute force, do it. But if you do sine of pi 8s, then once you've got that done, sine of pi 8s, then press enter. And then with your answer, reciprocate. That way you don't forget one of these parentheses and wind up with bad syntax or wrong answer. Okay? Now, here's the key though. Whatever answer you get, if you're doing cosecant, you better have a number that's greater than 1 or less than -1. If you don't get that, you've done something wrong. Okay? If you were doing sine or cosine, or sine or cosine, your answer should be something between -1 and 1. Secant and cosecant outside -1 and 1. In other words, less than -1 or greater than +1. Okay, so that would be that would be an acceptable answer. No way of knowing it's correct. So let's do one. And here again, they give you the answer and say, this is what you do. Now, see what you get. So let's us do it. The question is, what is sine of 2/3 pi? Or sine of 2 pi over 2. You know the answer to that already. Anyone tell me? Radical 3 over 2, is that what you said? Yeah. Okay, let's think about it. Yeah, sine is the y value, and 2/3 pi, though, is in the, which quadrant? Second quadrant, but sine is positive in the second quadrant. So I think it's positive √3 over 2. Okay? Yeah. Sine is the y value. Yeah, that I think is the answer. Now, you're not going to get that on your calculator, are you? Because it doesn't give you √3s. It's going to give you some decimal number. Okay, so you can either plug that in and see what you get. Okay. How do you do this on the calculator? And it's really straightforward. But the first thing you do is, what mode are you? What do you do? What is that? Radian mode. You've got to be in radian mode. So get in radian mode, and then once you are, type in the sign, and as soon as you do that, most calculators will open that first parenthesis for you. Okay? And then you just do 2. Now, some calculators you can do 2 pi. Others you have to do 2 times pi. And then you do a divided by 3. And a lot of times you don't even have to close out the parentheses. I like to, just because I'm used to computer programming. You better do that. And then press your equal key and you got your answer. Okay? If you're in radian mode. If you're not in radian mode, you're dead in the water. Okay? And somebody do that. See what you get. Okay? Let's see what they get.
What did you say you got?
0.66025.
Okay, did you say 0.86? Okay, okay, yeah. They got, yeah, same thing they did.
Okay, so that was the A part. How about the B part? Cotangent of 1.5. How are you going to do that? Be sure you're in degree mode. That's not 1.5 degrees unless there's a degree symbol by it. So you know you have to be in radian mode, and then what do you do then? Once you're in radian mode, what do you do?
What do you type on your calculator?
So you do parentheses, tangent, 1.5, close parentheses,
X to the minus 1. That's a key on your calculator, and then the equal key. That certainly will give it to you. What I usually do myself is do 1 over tangent 1.5. And that gives it to you too. 1 divided by tangent 1.5 equal. Once I'm in degree mode, I mean radian mode. Okay? And frankly, this is 1, 2, 3, 4, 5, 6, 7, 8 keystrokes, and that gives you your answer. This is 1, 2, 3, 4, 5, 6, 7, 8 keystrokes. You don't even need to get 8 keystrokes, and that gives you your answer too. You know, so it's about 6, 1, half dozen of the other. I do it this way, otherwise I have to make sure I've got both parentheses there, and I don't always. Okay. What do you get when you do it?
0.0709.
Okay. 0.0709. Yeah, perfect. Okay. There's nothing really, no easy way you can look at a tangent or cotangent and know whether you got it right or not. Sine or cosine, secant or cosecant, you can tell if you're in the right ballpark. But tangent and cotangent, there's hardly a way to tell. Well, not. Yeah. Here's what I think when I'm dealing with that. 1.5 radians. Remember, 1 radian is about 60 degrees. It's 56 or 57 something another degrees there. And 1.5 will be half again that. So you're awfully close to vertical, but you are not quite there yet. So you're still in the first quadrant, and but an angle very close to 90 degrees. Not quite there yet. Now, you haven't done this yet, but your cotangent looks like this. So you're awfully close to the pi halves, and that's a very small number. So yeah, I will buy that answer. You don't probably know enough to get there. But that's the end of 4.2. We'll begin next time. I take it the way y'all are zipping things up that we must be out of time. So let me mark. We'll start next time on the vocabulary. Not there. Okay. And homework exercises here. Do either 5 or 7. They're both at calcchat.com. Do either 7 or 9 or 11. They're both at calcchat. Do any of the odds 13 to 21. They're all at calcchat. Then do any of the odds 23 to 29. They're all at calcchat, but 23 is at calcview. Do any of the odds 31 to 35. They're all at calcchat. 31's at calcview. Do any of the odds 37 to 41. They're all at calcchat. 37's at calcview. Do any of the odds 43 to 47. They're all at calcchat. Then do 49. That's a harmonic motion problem. We haven't done one like it, but it's pretty simple to do, I think. If you have trouble with it, ask in class.
And then there's a true false, two true false, 51 and 53. They should be at Calc Chat as well. There's a conjecture that you can do it if you'd like. It's not necessary, but you can if you'd like. That's 55. There's an error analysis where I really don't like you to do. I mean, I don't mind if you do, but just remember, they're giving you something that's wrong, and I hate you to look at something that's wrong, but you can do that. It's not bad. And using technology, there's another thing you can do there. But if that's beyond what you understand, don't sweat it. There's a think about it, number 61. I'm not sure that's a Calc Chat, but you can certainly take a look. And once we've done the vocabulary, we'll get started on 4.3. Any questions?
All right. We'll pick up and go from there. I hope we're out of time. I was counting on the zippering. Yes, you're right. We were. See you Thursday.
So yeah.